identifying technologies that can make aviation jet fuel, and then running through the full approval process at the International Fuels Committee, because you have to get the fuel approved to incentivize commercial production. Nobody's going to put $100 or $200 million in the ground for a plant to sell a product that's not yet approved yet. So we put quite a bit of effort on accelerating fuels approval. We have a group of BOEING look at feedstock pathways, and again, focus on sustainable feedstocks. And in the previous presentations and presentations we heard earlier the last couple of days is very important. We support sustainable criteria around the world, and also look at developing feedstocks, and also looking at approving these feedstock sustainability requirements. Airports infrastructure. Again, looking at what parts of the world, aviation is somewhat unique. We don't have thousands and thousands of filling stations like you do for ground transportation. We have relatively few number of airports around the world. Where would it be best technology that we can implement some of these technologies at quickly? So we have a group looking at that. Commercial production. We're also looking at how can we incentivize commercial production? Where can we put our expertise as a company and as our influence, as well as our guidance and policy, and to where can we put the commercial production facilities. And finally, policy support, advocacy. So not only in the United States but around the world, BOEING is very active in support and advocacy for bio-derived fuels for aviation. So these are the 5 main focus areas within BOEING that we have, looking at how do we incentivize and catalyze bio-derived fuels for aviation to meet the 600 million gallon per year target. To give you some idea of what activities we have around the world, we have activities almost in every continent, and they vary from what we call road mapping activities, where we have one going in Australia, where we look at the country as a whole. So what can be grown in that area? What is the logistics challenges that we have? What does the distribution system look like? Preparing these studies, give it to the government officials so they can give them guidance of decision-making policy. We also have a very large activity in China. We have a memorandum of understanding with the CAAC, which is their airline regulatory agency, Air China and PetroChina. BOEING helped form the Sustainable Aviation Fuels User Group, which is a collaboration of multiple airlines and control over 25% of the world jet fuel consumption. So a very influential group. And that Sustainable Aviation Fuels User Group has signed commitments at the CEO level to help incentivize and reduce the carbon footprint by accelerating bio-derived fuels for aviation. We're having feedstock development projects. One of the ones is the Masdar Institute in the UAE, where we're looking at salt-tolerant plants and what can be grown in more saline-type environments for feedstocks, and how do you process that feedstock. So we're covering not only fuel production, road mapping activities, as well as feedstocks, but also advocacy as well all around the world. So to give you stats on some of our progress, BOEING, we contribute on a number of commercial and military flight tests, and then these flight tests were done on the bio-derived oils that's almost approved at the International Fuels Committee, both on commercial airlines, 3747s and 1737, but also on military aircraft as well, C-17 and the fighter aircraft, to show that these fuels meet all the performance requirements that we have for our current jet fuel, and all these test flights meet or exceeded those expectations. And again, also we've flown on helicopters as well too. So all that, the testing that was done in support of these flight test programs fed into the body of knowledge that we presented to the Aviation Committee for approval of these fuels for aviation. Again, some of the things we have going currently around the world are these road mapping, regional assessment activities in Australia, China, and Mexico. And we're also we're supporting global sustainability standards consortiums. And where we're at, what's in the future? What are we looking at next? We're looking forward to the approval of the new jet fuel specification, include bio-derived fuels from bio-oils. And again, as mentioned, should be completed the third quarter this year. We're continuing to emphasize on sustainability and regional commercialization and getting the first large-scale production facility up and running to produce a bio-derived fuel for aviation. We're encouraging to expand the feedstock processing pathways development, looking at different feedstocks. And one of the feedstocks, some of the feedstocks I mentioned earlier, the alcohol to jet, the pyrolysis route. We're looking at how we can help accelerate those type of approvals of those type of fuels as well. And again, our main goal is reaching market viability in 2015. And that's all I had today. Thank you so much.
Buenas tardes. Soy Fernando García con AMYRIS de California. Por favor, voy a hablar en inglés. Good afternoon. I am Fernando Garcia with AMYRIS based in the California office. What I would like to present to you today is our emerging jet fuel technology and early fuel property specifications that we have that industry partners have tested our fuel. And so I would like to give you an idea of what fuel performance you can expect as we develop our fuel. Our jet fuel technology platform is identical, is similar to our platform that we are using for our renewable diesel fuel and chemicals that our CEO John Mello described in the first day of the conference. You see in our technology platform, our feedstock is Brazilian sugarcane. We are producing product for testing through contract manufacturers in Brazil, such as Biomen, and in the future, the plant under construction in San Martino. Our core technology, as you see for our products, is the biotechnology, that is the engineering of the yeast that is used in the fermentation process. The parent of our yeast is identical to the yeast that is used to ferment and produce alcohols. Our technology is to change the DNA of the yeast such that it will consume efficiently and at high yields the type of sugars that we feed it, such as Brazilian sugarcane, and it will produce the target hydrocarbon. Our technology is producing a hydrocarbon, and depending on which genes that we can add or remove from the yeast, it will produce or yield the hydrocarbon product that we are pursuing. Our jet fuel project is actually in cooperation, development project is in cooperation with Total. We have a joint project where we are sharing both technical capabilities and personnel on the project. Our goal is to produce a drop-in aviation jet fuel, Jet A, A1 specifications, that will be converting plant sugars, such as Brazilian sugarcane, into, again, a direct hydrocarbon. The goal is to outperform petroleum-derived fuel in both exhaust emissions and greenhouse gas emissions, and actually and performance quality, which I have some data to show you and give you confidence in that. Again, our goal is to produce a drop-in fuel. As Jim just commented from BOEING, we fully understand that our fuel has to be drop-in, has to be transparent, not only to the airframers, the engine manufacturers, but the distributors throughout the world, airports. We are pursuing both standards validation. The two global standards organization is ASTM and DEFSTAN in Europe. As you might know, AMP in Brazil refers to the ASTM specifications. So we will pursue a fuel validation for the U.S., European, and Brazilian markets as our initial markets. And as Jim indicated as well, we would pursue the OEMs, the airframers, and the engine manufacturers validation and acceptance. What is our process? It's quite a direct, simple process. I would like to refer to it as direct sugar to hydrocarbon. That is, we take biomass sugarcane. Again, our initial plant will be using Brazilian sugarcane. Using our yeast that we have designed, go through a fermentation process and yield a direct hydrocarbon out of that process. Now, we call it a crude hydrocarbon. It does need hydroprocessing to finish the fuel into the specifications that we are targeting. And again, the hydroprocessing will yield a product that would be meeting the ASTM and DEFSTAN product specifications. I would like to give some information on our candidate jet fuel. What do I mean by candidate jet fuel? This is, again, a fuel under development. So we are still engineering the yeast so that we hit the performance targets that we'd like. We will, again, be using sugarcane as our fermented sugars. Stakeholder in the industry has already performed some preliminary analysis, such as GE Aviation has performed ground tests. U.S. Air Force at Wright-Patterson Air Force Base has performed properties testing, fit-for-purpose testing. We also have some programs at universities such as Princeton University. All of this testing is to confirm our target, which is drop-in performance. What can the market expect? The market can expect a drop-in renewable jet A1 fuel that will outperform conventional petroleum. Now, to give you an idea of what chemical structure are we speaking in our candidate jet fuel, presently we're looking at 3 molecules in the synthetic component. Our goal is to meet the existing specifications with a 50% blend, 50% petroleum, 50% amyris components, which presently we're looking at 2 C10 molecules and a C15 molecule. What is very interesting to see here, the C15 molecule issue on the graph here is actually our AMYRIS renewable diesel. So we are taking and leveraging the development that we have done with our diesel fuel, blending it with new molecules, which require a slightly different fermentation process from a standpoint of the yeast, blending those components, and then finishing it with petroleum, again through the fermentation and hydroprocessing. In the data that you'll see shortly and in all the testing we have done, the C15 molecule has been produced from sugarcane. The C10 molecules have been derived from plant-derived chemicals. Okay, so I want to ensure transparency that the data you'll see in our testing is based on cane-derived C15s and plant-derived C10s. Now, why are we doing that? We're doing that because we're still developing the yeast to reach the yield rates and the efficiencies that are needed. But as the speakers before me spoke, we need to have insurance that once we make the pathway, we will meet the product specifications. We will have a market to sell our product to. So this allows us to validate our target molecules while our biologists and chemists are working on the pathway. Examples of performance and what you can expect. What we have here, this was measured by Wright-Patterson Air Force Base in the United States. The dark blue line is the JP8, the military version, similar to Jet A. Distillation, and there's, the graph is a percentage of what is referred to as distillation. At what point does the molecules boil? Okay, so it's very classical assessment of petroleum characteristics, and what you see is the dark blue is petroleum. The orange line below is the C10 molecules, the 2 C10 molecules I explained earlier, and then the light blue line is what we refer to as AMJ 700, C10s and C15s blended 50% with petroleum. And I think what you could see here is that most impressively, we are approaching the characteristic of petroleum. Now, keep in mind, this is the specification of petroleum. It doesn't mean it's the best distillation. Okay, it is just what petroleum is. And I think through working with the airframers and engine manufacturers, for future generations, we could look at what is a better distillation. Today, we're going to validate our fuel subject to petroleum specifications, but